So, ABCD is a rectangle with diagonal AC. XY is parallel to BC, and XY intersects AZ at Z, as shown in the diagram. Prove that AX equals XB. So AX being from here to here, AZ being here to here, that automatically brings my attention to using that triangle there. Okay? And then XB being this part here, and ZC being that part there, that brings my attention to using the full triangle. In the past, we've never used like a trapezium. We always use, it's a similar triangles exercise. So we got to use two triangles. So the logical choice is to use the big triangle followed by the small triangle, okay? Now, I'm going to set about, first of all, proving that they're similar, right? So we'll just use a more appropriate. So I'll just call this part here what's it? AXZ is this triangle here. And then the next one's going to be ABC. Like so. So the triangle on the right is the big one. The triangle on the left is the small one. Okay. Now, how do I know that these two guys are in fact similar? Well, it says BC is parallel to XY. Can anybody in the class give me what is the name of a line when it crosses two or more parallel lines? A transversal. Yeah, you would have done that the other week, right? Transversal. Now, what happens next then, guys, is that you're going to be asked to, when you have a transversal, you can then say that's corresponding to that one. This one's corresponding to this one. And this one up here is the common angle. So green equals green, red equals red, and then blue equals blue. Now, if you were asked the words, like if you were asked, you're asked to prove that, aren't you? So you're really asked to spell everything out. Is that right? So you'd actually have to write this out really formally. Like I'm talking super formal here. Okay? So I'd have to, when I say green angle equals green angle, I'm actually going to have to prove they're similar triangles. Okay? So I write down the triangle AXZ, and then on the other side I write down the triangle ABC. And I go about proving they're similar. So I write down, I'll start off with the red angle. I say angle ABC equals angle AXZ, reason being, anybody? Corresponding angles, okay? Then I go for the blue one. And what's the reason for the blue one? AZX equals the other blue one, which is ACB. Once again, corresponding angles. In a test, write it a second time, okay? Now, then finally the last angle, which is the green one. Anybody? Angle AXZ equals angle BAC, and the reason being? Same angle, isn't it? Or you could say that all three angles have to add up to 180, and since the other two are the same, it means the third one's the same. Just what we're then going to do, once we know they're similar, what we can then do next is, you'll need to keep that, but I'm just going to rub it out just because I need board space, okay? Now, you go back up to the top and you go, alright, my targeting, what is my targeting? We'll start off with the very top one. Does any triangle have AX in it? The small triangle has AX in it, right? So, and would you agree that the equivalent side in the large triangle is AB? Yeah? So would everybody agree that this triangle here is some number bigger than the small triangle? So this means AB divided by AX will tell me how much bigger the big triangle is when compared to the small triangle. Imagine 10 divided by 5. That will tell me that it's twice as big. Alright, then I look back up again and go A to Z. Where's A to Z? A to Z is this side here. That sets my targeting off for A to C. In a similar argument, imagine that AC is 12. That would mean that one is 6, because it has to be twice as big. Okay? So therefore, by that logical argument, I could say, I just want to get rid of that 5 and 10 because I just made them up just to sell a point home. But I basically say that AC divided by AZ. Big divided by small. Okay? Now, I then look up here and go, what doesn't belong? There's some letters there that don't belong. And what are they? Okay? So I'm looking up and I'm comparing it to what I'm trying to turn it into. What doesn't belong? AX belongs because it's in the answer. And AZ also belongs. What doesn't belong, however, is there's no AC in that answer and there's no AB. Is that logical, yeah? Now I'm going to get rid of AB and AC using the following way. I go up to AB and I can rewrite AB as AX plus XB. Does that make sense? It's the only way I can get rid of it. No other way comes to mind. So what I do is I change AB, which is here. I change that to AX plus AB. And it's still all over AX. Now, I go to AC, and is there an AC on the top? No, there's not. So what can I do this time?
AZ plus AZ.
So, where was I? AC doesn't belong because AC is not in my answer. Would you agree with that? Yeah. Okay. So then I say, fair enough. I replace AC with, what am I going to replace AC with? AZ plus ZC. AZ in a bracket plus ZC. Sorry, I drew those two brackets slightly differently. I meant to have lines on both sides. Just say it's the length, okay? Now, and then that's once again all over AZ. Now, this question is very similar to a question like this, where if I was to say, if I said x plus 5 divided by 3 equals x plus 4 divided by 6, how would you sort this? Oh, sorry, not 6, because then you can multiply one side by 2. How would you sort this question out in the exam? You bring the 7 up beside the x plus 5, wouldn't you? And you'd multiply the 7 into the first one, then into the second one. You'd bring the 3 up beside the x plus 4, and you'd multiply it in both times. This here is actually no different whatsoever. We're going to bring the AZ, and it's going to multiply by the AX, and then it's going to multiply by the AB. Does that make sense? Yes?
You just go over time, it's just...
Yeah. It's going to go to the AX, then it's going to go to the AB. Okay? So, can anybody tell me what I get? AZ by AX when I multiply it? Anybody? AZ by AX? It's AX multiplied by AZ. I can't actually multiply them, so I'll just put them beside each other. AZ multiplied by AB plus AZ AB. Okay, the equal sign is in the middle. Can anybody in the class tell me what do I do with AX here? Oh wait, different colour. What do I do with AX here? It's going to multiply by the AZ and the ZC, yeah? And what happens when I multiply them like that? Anyone know? Equals AX AZ or AZ AX, whichever way you want it. It's like 2 multiplied by 3 being the same as 3 multiplied by 2. And then the other one, ZC by AX. Now, is there any two numbers on both sides that got to be identical to each other? I'd argue that AX multiplied by AZ on one side cancels with the AX AZ on the other side. In the same way, 5 plus X equals 5 plus y, the 5's can cancel because you're adding 5's onto both sides. Okay? So that's what I did there. Now, what I'm going to get next is AZ over AB, right? So AZ by AB equals ZC by AX. I have to go back to the very top and have a look at what's here. I want the AX in the top left position. I want AX and CY to the left. Is everybody right with that? AX top left, CY bottom left.
Not the next question.
Oh, sorry. Yeah, you're right. I want the AX top left and the XB bottom left. So, currently speaking, the AX is top right. So what I can do is I can just do a spin around. Me basically saying 3 plus 2 equals 5. It's the same thing as me saying 5 equals 3 plus 2. Doesn't matter what way it's around. So I'll just rewrite like this first and foremost. Now I have that AX in its desired position. What combo did I say I need underneath it again?
XB.
Was it?
XB.
XB.
Right, yes. Wait,
XB. Where is XB gone? Oh. Just one CAX, yeah. That's not actually AB, it's actually X to B. So anywhere I see AB, I'm just going to change to XB. Sorry about that, guys. Foolish me. It's an easy fix to make, though. You can just, anywhere you see that, you just change it to X. You saw that. And then, yeah, it's down there. No, it's not. Nothing wrong with it. Okay, guys. AX over XB is the same thing as AZ over ZC. Now, if you're wondering how I did the last part, it's just cross multiplication down. So, as example, if you had 5x equals 3y, yeah? The 3 is multiply on the left. What would that make it? It's multiplication on the right hand side. What does that make it on the left hand side? Division. So you could have x over 3 on one side, and you could have y over 5 on the other side. That's the sort of cross multiplication that I did up there. Is that right with you? Okay. Finally, the last question is AX. Guys, AX over CY. So where is C to Y? AX over CY is equal to XZ over YZ. Well, actually we have all the workings for that already done. That's actually going to be really quick. It's going to be very easy to do that one. Okay? So, all I have to do is, where is my targeting going to be is the question, okay? What am I going to target for this question to get 10 marks on the board, and why am I targeting that particular section, right? If I look at the letters, and once again I'm sort of just going to start from relative scratch here. Oh, what is that? No. Okay guys, I'm going to start from I'll start up here, okay? Okay, now, what I look at here is A to X. Guys, just be patient, you can learn a lot here, and there's a lot of marks we picked up in the next 2 minutes, okay? AX, you look at AX and go, okay, A to X, no bother. I'm using that triangle there. Then you say, it says X to Z. Definitely using the triangle AX set. Would you agree with that? A to X to Z. Okay, the next one. See, it says CY and YZ. What's the location on the triangle on that one? The little tiny one to the right. Everybody alright with that? Now, I write down both triangles separately. Now, as it turns out, they're actually they're going to be similar triangles, so I'll just reduce the size of the one I already drew, and then maybe just spin it around like that to make it look like that one there. Okay, so that's ZYC, that's AXZ. Now, let's have a detailed look at how we're going to prove this. I will say that this one here is vertically opposite to that one there. Everybody alright with that? I will then say, now once again, you got to write this down formally, don't you? So you have to write down the angle AZX equals the angle YZC. The reason for that is they're vertically opposite, okay? The next one after that is you're going to then say why is let me see, why is this blue one here the same as that blue one there? They're 90 degrees, but it doesn't necessarily say that. Just say it's a it says a rectangle, sorry. And then it says that AX is parallel to BC, so you're allowed to say they're 90 degrees.
Wait.
Yes.
How come you can say the 90 degrees?
It says it's a rectangle.
Yeah.
And then it says BC is parallel to XY. BC has to be at 90 degrees.
Yeah, okay.
Okay. You could also argue alternate angles. It's a Z of sorts.
That's right.
Okay. So you're once again going to say what, guys? Excuse me, lads. A bit of patience, please. Okay. That was the red one. Sorry about that. Next one I'm going to do is the blue one. So the blue ones are the angle AXZ equals the angle ZYC. Okay, and we said they're 90 degrees or alternate. Take your choice. The last angle is the green one. Any reason they're the same? Alternate as well, or the other two angles, yeah, all three angles have to add up to 180. Yeah? Okay, guys.
No.
Okay, guys. Now that we're here, we've proved that they're alternate, right? We now look at the solution and we pick the side we're looking for. AX on the top left. AX is the big triangle. So I pick A to X. Now A to X is stuck between green and blue. So AX, the big triangle, divided by the small side, that's the same one. So what one do I put underneath? YC. So for instance, that could tell me it's 2 times bigger for all I know. Then I look up at another target up here. By the way, YC, same thing as CY. I then look at XZ, and where's XZ located? Blue to red, and that's XZ blue to red. So it's blue to red on the other one, which is ZY. And I have officially proven that theorem there. Okay.